Welcome. Cube roots. Yeah, we're at 15 seconds and I hardly said anything. Yeah. Let's try it. All right, so you're not going to see a whole lot of this, right? But we've done radicals before, and I want to go through this process again. Now, this problem's a little different than the one we did yesterday, but I want to break it down for you because some of y'all looked at me and it was like, and that was partially my fault too, because I want to give you some kind of step-by-step. All right, let's break down what we know. We've done radicals and exponents the whole time, so break down what you know. I know this is going to break down to the cube root, right, of 405. And then it's also going to break down to the cube root of x to the fourth, and it's also going to break down to the cube root of y to the fifth. Okay. Basically, the number that's kind of in that little crevice there is telling me how many sets of 3 can I pull out. So remember the kind of analogy I gave you yesterday. Whatever is underneath the radical sign's in jail, right? And if you can pull a set of that many out and only that many out, then it comes out of jail. It's free. You can go home, can hang out, whatever. But whatever can't get pulled out, unfortunately, gets stuck in there. So let's hold off on that for now because that's the most challenging part of it because it's not a perfect cube. Here, how many sets of 3x's can I pull out of there? Well, there are 4 x's in there, so if I have to pull 3 of them out at a time, I can only pull 1 set of 3 out, which means that 1 x is going to come out of that. But what's left? And what's left is only 1 x. Unfortunately, that x has to stay there. So this is what this breaks down to. All right. Here, I need a set of 3 y's. So only when it's 3 can they come out together. Now, only one of them will be able to do it because there's only 5 total. Now, if there were 6 there, I could pull 2 out, but I can't. So there's only 1 set of y's. So 1 y comes out because that represents the 3, and there are 2 left. So I have to represent that with a square. Those aren't too bad. Okay, and we'll do another one in a minute. Here it becomes the issue. Basically, I still want to look for factors, right? And the factors, you want to try to find the largest perfect cube, right? And perfect cube rules we'll go through again a little bit today. But 8 is a perfect cube, right? Because 2 times 2 times 2. 27 is the next one because 3 times 3 times 3. So if we follow that pattern, 4 times 4 times 4, 64. Good. So I'm looking for the biggest perfect cube. And we did this yesterday. The biggest perfect cube I can pull out is 27. I'm still going to write that little 3 there so we can understand it. Now, it just so happens that when I divide 405 by 27, its other factor is the square root of 15. Okay, now just leave it like this for now so it's notation, you understand. Now I've got a bunch of stuff here. And I can't go any further, right? Well, with this one I can because I know what the cube root of 27 is. It happens to be 3. So now I'm left with this to this to this, and I'm going to make some arrows, and that's crazy. Now let's just kind of put it all together. All the stuff that came out of jail goes in the front. The integer comes out first. And we'll just keep it in kind of like alphabetical order, right? So 1x made its way out. Hooray for you. 1y came out. Good. Now I don't have anything else I can pull that came out. Now I've got to kind of rewrite the stuff that was left in jail. So 15, so the integer again comes first. And then I've got an x followed by a y squared. So this is going to be my final answer here. 3xy, and the donation there, right? So that was my mistake yesterday. I didn't put that there. Just so you understand, because y'all are looking at it like, well, how come I can't pull a y out? Well, that's why, because that was my boo-boo. So sorry. Final answer there. Yeah, so that's what that turns into. Okay, let's do one more problem. And I'll make it a little bit easier for you so you can try it on your own. I'm just going to erase this whole thing. All right. Y'all doing okay? Good? Yeah? All right. Let's just make it easy. All right, so... okay. I said it was going to be easy. I lied. Okay, so let's see. Try it on your own. Pause me if you want. If you're not, I'm going to go straight ahead with it. So let's break down what we know. How many sets of 3 x's can come out of there? 2, right? So I have to write that as a 2, a square up top. And what's going to be left? Well, if there's 2 that come out, 1's left, right? Y to the 8th. Again, 2 can come out, right? So y to the 2nd. But what's left? 2, right? So then I gotta write that as that then. And then a z. How many sets of 3 z's can come out? Well, 3 of them can. Right? So So z to the third, nothing underneath. Okay, got to come out, and the cube root sign goes away. Now, 125, perfect cube, right? 5. So 5 comes out, period, end of story. Now I can kind of squeeze it all back together. So I'm left with 5x squared, y squared, z to the third. And underneath, we're just left with a lonely x and a y squared. So check it. This is what this turns into when I'm talking about cube roots. I did it again. So make sure you get the 3 there. All right. Check yourself, where you wreck yourself. Questions coming at you. See you later.